So here are some more examples of the kind of problems you'll see in your 7.2 day 1 homework. So we'll just keep on moving along here, and we'll call this first example, example 7, because we left off with 6 in the other video. So here we have some where we're just simplifying radicals, like the 4th root of 81, x to the 8th power, y to the 12th power. So this time I'm looking for a 4th root, so I'm looking for things that happen in groups of 4. I do want to remind you that on your calculator, if you have a graphing calculator or if you're using the graphing calculator app on your Chromebook, and if you have any trouble getting to that, please email me and I can walk you through that step and finding that on your Chromebook. So if you push the math button on your calculator, you can go down to number 5, and it will let you put whatever kind of roots you want. Some of you may have a calculator where there's a little square in this spot right here. Some of you may have, like mine, where it says answer, and you can go and change that to a 4. So I'm just going to see what the 4th root of 81 is, and it just happens to be a 3. So that means where the 81, that would be 3 times 3 times 3 times 3. 4 3s go right there. So that pulls a 3 to the outside. And let's see what's left. Now I want to know how many x's, how many groups of 4 x's would I have? So this would be x to the 4th and x to the 4th. So there's 2 of those. So it would pull 2 x's out, so that leaves an x squared on the outside. And then this would be y to the 4th, y to the 4th, y to the 4th. So that makes 3 x's on the outside. So my answer would be 3x squared y to the 3rd. Let's do another one of those, and I'll try to be a little more clear here. So I'm going to try the cube root of 216, x to the 12th, y to the 9th. So I'm going to try math and then pick cube root this time, which is 4, and see if 216 actually has a cube root, and it does. The cube root of 216 is 6, so that means this must have been 6 times 6 times 6. Now I have to think of how many x to the 3rds would be in x to the 12th. There's x to the 3rd, x to the 3rd, x to the 3rd, x to the 3rd. It takes 4 of them to make 12. So on the outside would be x to the 4th. Because this would pull an x out, this would pull an x out, this would pull an x out, and this would pull an x out. So 4 x's get pulled out. How many groups of 3 would be in y to the 9th? And there would be 3 of those. So this would be 6, x to the 4th, y to the 3rd. All right, let's move on to example 9. This is going to be a similar type problem, so you could stop the video and give it a try yourself and see if you can do it. So I'm trying to find the 4th root of 81, x to the 18th, y to the 16th. So I know that the 4th root of 81 is 3, so there's a 3 on the outside, so that's gone. And now I want to think about how many groups of 4 would be here. Well, x to the 4th and x to the 4th, that would be 8, 12, 16. So 4 x's would make 16. So I know I want x to the 4th on the outside, but I only use 16 x's, so I'm going to have 2 left on the inside. And then how many groups of 4 would be in 16? And that would be 4. Now, they're not really going to let you leave an answer like this. Even though this is correct, you have the 4th root of x squared. But because this number and this number are divisible, that means you're going to have to simplify. And let me show you what I mean by that. This is 3x to the 4th, y to the 4th. But this is x to the 2/4 power. And 2/4 reduces to 1/2. So I would say this is 3x to the 4th, y to the 4th, square roots of x. So back at this particular step, I could have just crossed that off and made it a 1, and crossed that off and made it a 2, and reduced at that spot right there. All right, number 10. We're going to move on to multiplying. The 6th root of 2 times the square root of 2 to the 5th. Notice this time that our radicals don't have the same index number. So I'm going to have to do something to try to get to combine these. One thing I do have to have is the same number on the inside of the radical. The radicand has to be the same. So I'm going to turn this 2 into 2 to the 1/6 power, because that means the same thing as the 6th root of 2. And I'm going to turn this 2 into 2 to the 1/5. I'm sorry, that's a 2, so it'd be 2 to the 5/2 power. So because these have the same base number, and this only works because they have the same base number, I can add the exponents. And now I have to get a common denominator, and the common denominator of 6 and 2 would be 6. So I have 2 to the 1/6, plus I'm going to change that to 6 by multiplying by 3, so I have to take that times 3. So it'd be 2 to the 16/6, but that reduces by 2, so my answer would be 2 to the 8/3 power, and that is simplified. Let's do another one like that. Again, anytime you're ready to stop watching and engage, you should pause the video, try the problem yourself, and then come back and see if you're right. So we'll do 2 more of these. Here's number 11. The 5th root of 7 to the 3rd times the cube root of 7 to the 4th. So the only reason I can put these together is because they have the same base here. So I'm going to turn them back into their fractions. So this is 7 to the 3/5 times 7 to the 4/3. Remember that this becomes the denominator. So now I can put them together if I can get a common denominator and add. And what would the common denominator of 5 and 3 be? Yep, 15. So this becomes 9, this becomes 20. So it'd be 7 to the 29/15. And I don't believe that one simplifies, so you'll have to leave it just like that. If they asked for the answer in radical form, you would write the 15th root of 7 to the 29th power. All right, number 12. And then we'll take another break. The 6th root of 10 times the 6th root of 10. This one's nice because they're both 6th roots, so that means something's going to simplify here. So I'm going to change this to the 10 to the 1/6 times 10 to the 1/6, and I like this because they both have a common denominator. So this would be 10 to the 2/6 power, which is 10 to the 1/3.